Hello everyone. So today I will be taking extra class session for the course unit operations of particulate matter, which is nothing but the mechanical operation. And this is the extra week. Like the course was 4 week course, and in that we have uh, had thorough discussion about various uh, relevant topics, and then if you want me to go to the course what has been taught till now and what discussions are need to be done today. So let me just sign in, then I will be going to that. And the thing is, like this Swayam, uh, yes, through Google I will log in. Let me choose my email ID, and then in that this unit operation of particulate matter, we 4 week course has been completed, and in that you had the discussion about fluidization, sedimentation, and transportation of solids and filtration. So all the four topics have been covered thoroughly. So what is the status of the course? So let us see this. Here you see the unit operations of particulate matter, and examinations, uh, like this is another problem solving session. About that, you will be able to download the book from here. So all the books are here, and problem solving session things are uploaded here. So all the lectures and notes are being uploaded here, and in this assignment related discussions have been thoroughly done, and you will be having solutions for each week. So solutions are uploaded anyway. So you are done with this. So you started with the sedimentation, and in that sedimentation and the batch sedimentation test. So then you went for the centrifugal sedimentation and equipments. So sedimentation equipments and everything. Then in the next week, the discussion about the filtration started. So in that batch filtration and then the continuous filtration, both in constant rate and constant pressure, and along with the assignment for the week 2. Week 3 had discussion about the fluidization. In that, liquid fluidization and gas fluidization have been dealt with specifically in detail. The last week dealt with the fluidization and the transport of solids. So this is nothing but the conveying of the solid. So why pneumatic and various transportations are necessary. So hydraulic and pneumatic. So that's all. So these all the topics are already completed, and the purpose of today's course uh, is like today's class is like to tell you some of the more questions that will be related to the assignment problems, and that will be anyway beneficial for you to solve the assignments, as well as it will be helpful to understand the concept that had been taught in the class, and this will be again helpful in the examination. So whatever I will tell you in this particular lecture, those are of those will carry more important topics that or questions related to that will be asked in the final exam that will be heading up. So these are some books that we have followed. So anyway, everything is incorporated inside the lecture notes. Okay, so you are done with these things. So let me just have this. This is this I require today. So I will take it into the notes only. So it will be 2. So okay, so today's lecture, this is the extra class. Okay, this is the extra class. So anyway, every discussion that we will be having today is the one. So I hope I am audible. Yes. So this is like extra class. Mm, extra week. Okay, this is extra week. So in that, the question I will be starting with is which of the following. Let me just thin it down because this is very thick. So let me just yes. No, I think yes. Which of the following is correct about hydraulic and pneumatic transport? Okay, so the options are, let me see the options first and then so these hydraulic and pneumatic transports are the continuous operations. So these are these are used when you need to have transportable short distance transport over short distance. Okay, B is these are continuous operation. C is less manpower required. Requirement. And D is could be used in could be good for adverse weather condition. Okay, and possibility of following relatively shorter routes. Shorter routes. So, so you look at this. I will tell you the question is from the transport of solids, which is the conveying of solid, where you have been taught about different conveyors, and this whole discussion will be around that only. So, like this hydraulic and the pneumatic transport and their importance and what is the definition of them, and why they are that much beneficial when it comes to the application of these transportation systems or methodology into the real industrial requirement. So you just look at this. I will be giving 1 minute to solve this. Looking at the question and the options, you will be clearly getting that this pneumatic transport is physically used with long distance transport. Here it is written short, so that's why this is not correct. This is a continuous operation, obviously. Less manpower is required in this, obviously, because these are the continuous process. Once the pipeline is installed, just you have to just have the your solid particle fluidized, and if that condition is met, this could be very good methodology, and this could work in any adverse weather condition. And there is a possibility of following relatively shortest route between two destinations in which the transportation is required. So B, C, D, E, B, C, D, E are correct. So if you compare it, then you will be in a situation to actually appreciate what actually this, what uh, level of ease you will have when you go to you use this pipeline transportation, which is pneumatic or hydraulic. So if you see the automobile or railways or waterways, airways, and pipeline transport. Okay, so these are mode of transport. Okay, these are mode of transport. Mode of transport. And these are specific transportation capacity. Transportation capacity. Unit is kg per kilowatt. And the last one is power consumption. Watt per kg kilometers. So if you see this from here, if you see this from here, things are like this. This automobile, the specific transportation capacity, if it is 65, no, it will just be like that. So this is what it is 65 to 200, and for this power consumption required is 0.14. Whereas railways, though the capacity is more, power consumption is also more. Waterways are better one. You see here power consumption is really less because the flow is helping in the transportation. Airlines very less capacity and very high power consumption. So this is the least efficient if it comes to value for money. But the pipelines that we are talking about is the best. 40,000. And the power consumption is least. Less comparable to the waterways. So if you see this comparison, then things will be more clear to you about the how less manpower required and how efficient the hydraulic and the pneumatic transportation system is. Now let us look at the next problem, and the next problem is based on uh, this pneumatic transportation, and so the pneumatic transportation is so what is correct statement or means about pneumatic transport. So if you see this, option A is it uses liquid to convey solid material. Okay, it uses gas to convey solid material. No dust contamination will be there to the content which is being conveyed. No direction cannot be varied. High maintenance cost. can handle multiple products with one system. Particle must be dry. Particle must be dry. Here there is possibility of product breakage. Product breakage. So there is the possibility that there could this wear and tear can happen. So is it true? The case and G is wear and tear on the pipes. You have to tell which statement is correct about the pneumatic transport system. So I will be just putting it here. Yes. Let me just increase it further. Yes. So look at the problem and try to solve it. So yes, what is the correct statement? Or statements about the pneumatic transportation. First, it uses liquid to convey solid material. It uses gas to convey solid material. So you just look at it, and meanwhile I will be telling you the answer. Just think about it for a minute. And the next question that I want you to solve is the continuous discharge elevator. If you understand this, then things will be okay. So this question is let me take it one. Which of the following is correct about so I will take it just after some time. Just wait. So this question, the options will be it uses gas to convert. So this is correct. This is not correct. No dust contamination. There is no dust contamination gas. This is correct. So because this will be closely packed, so there will be no dust contamination. Flow direction can be varied. So this one is not correct. Low maintenance cost. So this one is not correct. Can we have multiple products with one system? So this is tricky. So because one product is flowing and it is not mixing because the things are like if one product is there, then after a long distance of the medium, other product is kept, so they can go like a rail. So particle must be dry, possibility of product because it is there. So this is the disadvantage. So these are the disadvantages. So We are correct. So now you see the next problem that we are going to solve is this one. We just yes, yes. Which of the following is correct about continuous discharge elevator? Discharge elevator. Okay, so option A is there is there is gap between mounted, mounted bucket. Buckets. Option B is speed is 30 to 15 meter per minute. Speed is higher than centrifugal discharge. Okay. This will be used for lime, cement, and dry chemicals. You look at the options and come up with the answer to the problem. So I will give you 1 minute. Just look at it. Yes. So I hope you have looked at the problem. And as the question says, uh, this what is correct about the continuous discharge elevator? And this is a kind of bucket conveyor. So, so if you look at the options, then things will be easy. So, in the continuous discharge elevator, buckets are mounted without any gap in the chain or belt. So, there is gap. So, this is incorrect. Speed is correct, and this is slower than This is incorrect. This is correct. So if you want me to put the exact answer to this, let me just take the answer. The continuous discharge elevator. So then things will be easy for you. Okay, so now the next problem is next problem is let me just look at the different questions. Yes, the next problem is a numerical problem, and this problem is related to the sphericity. So I will be asking you to compare the sphericity values of different geometry. So then things will be easy. So this find the sphericity of find the sphericity for a cuboid of 10 is to 5 is to 1 centimeter cube unit dimension. Okay, so you have to calculate this, and then we will be looking at the things very well. So answer. So what is sphericity? So the sphericity is the one will be telling you how much the shape is different of any irregular particle if they are compared with the sphere. So a sphere's sphericity is 1. So if the I will tell you like particle shape. What is particle shape? The shape of the individual particle is commonly expressed in terms of sphericity. Okay, which is independent of the particle size. It is nothing but that depends only on the shape. So for a sphere, you know the sphericity is what? For non-spherical particle, the sphericity is defined as what? The sphericity is defined as phi s for non-spherical particle, like it is a cuboid. So it is surface area of sphere having same volume that of particle. So ऐसा is your sphere should be like it is having same volume as that of particle. to that of the sphere area of the particle, surface area of the particle. Okay, so this phi s is equals to what? 6 divided by dp, and everything divided by sp divided by d. If you know this, then things will be pretty easy. How things will be easy? You see, this phi s is what? Sphericity. dp is what? Equivalent diameter or nominal diameter of the particle. Meter or normal diameter meter of the particle. Okay, and the SP is surface area of one particle, area of one particle, and AP is volume of one particle. Okay, and this equivalent diameter will be defined as, if you want me to define this, this is diameter of the sphere of equivalent volume of the sphere equivalent. So the question that is in hand, let us solve that. So now the phi s is equals to surface area of sphere, that of the surface area of cuboid not. Okay, surface area of the sphere, that of the surface area of the cuboid. So here it will be 4 pi if the sphere is half radius r, and 4 pi r square divided by cuboid is what? This one. Then that side, so 2 LB plus BH plus HL. Okay, so now to calculate the equivalent diameter or nominal diameter, volume of the sphere is equal to volume of cuboid, that gives 4 pi r cubed by 3 equals to 10 into 5 into 1, which is equivalent radius or nominal equivalent diameter we are going to calculate. Equivalent radius comes out to be 2.285 meter. Okay. So the phi s comes out to be what? 4 pi r square is 2.285 whole square divided by 2, 10 into 5 into b plus b into h, 5 into 1 is h into 1 into 10. And when you solve this, you will get 0.504 to be phi s, which is the sphericity of the cuboid. Okay, so that's the thing. And if you want me to tell you this, how this came, this formula came, how, sometimes you can use it directly, but how it came. So that I could explain you in detail if you want. Like sphere area of so one important point is surface area sphere is very means 5 is less than or equal to 1 always, because formula, if you remember, everything, any geometry will be at the denominator sphere. If you remember, any geometry, if any geometry is there, this will be higher than 1. It will be higher than the spheres one, so this will be coming out to be the fraction. So if you see, this will be always less than 1. And if I tell you the rough value, so in the form of question also I can tell you. So question is, match the following sphericity value, sphericity value with the corresponding geometry. Options are column A, column B. So column A is sphere, cylinder, hemisphere, cube, force particle. We are going to compare the typical values for the given length scale. So this, we are given 1. This is A, this is B, this is C, this is D, this is E, this is F. So now here F you are having this A, C. So so how you are going to match it? So that is the question of this. You just solve it. You know that I just told that the sphericity of sphere is 5. So option A will be matching with option F. Okay. Then what is closest to the sphere? Anyway, hemisphere is closer. But if you see, and if I tell you the answer to this, the correct choice is this one. For example, sphere is more than cylinder. Is more than hemisphere. These are sphericity values of phi s. And this is more than 3. This is more than 4. And this is more than 4 particle. So if you see, one option I have to change, I think, and that is this one. Here we are having this. If you see this, definitely you are going to get. So this is for the close particle. Okay, this is for the sphere. For the cone, you have this. For the cone, you have that one. For the sphere, for the cone, you are having this one 0.79. For the cube, you are having 0.81. For the hemisphere, you are having 184. And cylinder, you are having 0.87. So this is done. So this was all about this particular question. And the formula that I wanted you to get the field is if is equals to SAF square divided by SAF particles. Okay. So now if you go deeper into the problem, then the question is derive phi s equals to 6 divided by dt. Okay. To derive it, where these are the values of different parameters. Where solve this and meanwhile we will be discussing. Yes, I hope you have gone through the problem. And the derivation is forward. You have to start with the basic equation and the basic definition of the sphericity. and then subsequently you will be able to get the feel about the solution. So let me just tell you how things will be going on. So for the time being, we will be starting with the basic definition. And here, if you see, this is the formula. So this sphere volume, sphere volume, sphere's volume is equals to 4 by 3 pi r cube, and this is equal to 4 by 3 pi dp by 2 whole cube. So this will give dp equals to 1.6 pi dp cube. Okay, so this will give 6 dp equals to pi dp cube is pi dp square equals to 6 dp divided by dp. Okay, now sphere surface area of sphere. Let's just delete it. Surface area of a sphere. Surface area of sphere equals to 4 pi r square by dp square by 4 pi square. So from here we will get pi dp square equals to 6 into 1. So therefore phi is from here we will get a phi is 6 by okay, right. So this was it for this course, and now we will be going for some other question. And before that, I want to just tell you like what we have discussed in the week one, because in the week one also we have discussed some of the problems. So this is the last concluding session for the problems, numerical problems that we have discussed. So it will be good if I actually tell you what has already been done along with some new problems. So there will be a kind of revision, and similar problems we will be getting in the final examination. So if you see this, there I have discussed one very important thing is this one. Like there has been one question that I will be telling you again. So the first question that we have discussed at that time was this one, which is which among the following is not a unit operation, and there you are asked to differentiate the unit operation and unit process, uh, and which is unit operation and which is unit process. And if you remember, there I have clearly discussed with you complete things, like complete classification of the of the things and uh, definitions. So if you see this one here, the complete classification have been made. So this was the classification that we have had. And if I have to take this to the same slide we are discussing now, then things will be okay. So these were the discussion. So like in chemical engineering, you study two things. First is the unit operation, and another one is the unit process. The unit operation. So let me just see if somebody can. Yes. So nobody can. So let me see. Yeah. No, I don't remember it. Yeah. Now it is okay. Yes. Yeah. So in that, if you remember, the chemical engineering dividing these divisions, and unit processes operations involve the physical changes, whereas the unit processes involve chemical changes. And in the chemical changes, we had oxidation, hydration, halogenation, and nitration. These are the reactions that comes into the picture of that. And another one is the properties of the solid. Uh, like mechanical equipment, heat transfer, mass transfer, they come into the physical changes. So here the mechanical operation comes into the picture. So accordingly, you have solved that particular problem. Okay. So now we are going to get some in-depth discussion about vacuum filter, and question is question is which of the following is correct about vacuum filter? Following is correct about vacuum filter. Filtration. Filtration. The options are: this is a continuous operation, and the other option is there is a convenient access to the cake for sampling. It has wide variety of material construction. Here, clean filter rates produce clean filtrates easy control of operation parameters. Operation parameters could be easily controlled. Okay. Low residual moisture in the cake. High power consumption by the vacuum pump. It is very difficult to do. Okay, so which of the following is correct? So you just look at the problem and then we will be getting, discussing the answer. Of it. Okay, look at the problem. I will be giving you 1 minute to follow. Yes, so I hope you have gone with the options and you have tried it. So Let us look at it and look at the solution for the same. So yes, so the continuous operation here. So obviously this vacuum filtration is the continuous operation. Yes, there is a convenient access to the cake for sampling. Wide variety of material could be used. It produces clean and convenient. Here operations parameters could be easily controlled. So this safety is this kind of provision is there. Low residual moisture in the cake. So it is not correct because there is a high residual moisture content. High power consumption by the vacuum. Yeah, that's why it is not that much reliable because uh, but if it comes to certain material then it is good and it is very difficult to clean. This is right. So this was these were the options which is correct about the same. Okay, so uh, now let us look at the next problem, which will be related to the which will be related to two things. Uh, which of the following is correct for this is from the fluidization. The question is from the fluidization. Which statement is correct for fluidization? Fluidization. Okay. So you solve this question. I will be giving you two questions, and you will be giving you 2 or 3 minutes to solve, and then we will be discussing it. So which statement is correct for the fluidization? Option A is uh, for Froude number, which is Fr, is less than 1. 1. It is aggregative fluidization. Fluidization. B. Froude number greater than 1. It is aggregative fluidization. Fluidization. Okay. Now other two options are for for Froude number greater than 1. It is particulate fluidization. Or for is a particulate fluidization. Fluidization. Okay. Yes. And another question that I want to possess is this one. Is this one. Let me just ask that question. Yes, so the question is this one. If n is less than 100, n is greater than 100, n is less than 100, n is greater than 100. So where n equals to Froude Reynolds number at minimum fluidization situation, rho s minus rho divided by rho L by D. And the first problem, the Froude number is Fr equals to U minimum fluidization divided by GT. So these were the options. So just look at the problem, and we will be, I will be telling you answers. So solve this. So this problem will be telling you the conditions at which the fluidization will be aggregative or the particulate. So that's the question. As you know, this Froude number is actually relating to the inertial and the gravity effect. So anyway, that could also be explained in terms of what are the forces leading to aggregative and the particulate fluidization. And we will discuss about the aggregative and the particulate fluidization too, along with the solution of the problem. So you will solve it. I will be giving you 2 or 3 minutes to solve it. So look at the problem and try to solve it. So I will be showing you some videos about the fluidization, and that will be anyway helpful for you. And after that, you solve the question that is given to you. Okay. So we will be looking at that. So let me just take the question. First, we have to manage both on the same screen. So let us keep it like this and just keep it here. So the thing is like this. Okay, so this is the problem in hand, and let us see how it is explained over here. So let it be like this only. So so we want to thank this five fluid dynamics for the video, and you see what happens actually in the fluid dynamics. Okay, look at this. You look at this. So this will be of helpful. Uh, this will anyway help you in learning the concepts and getting the thorough understanding about the same. So you look at the fluidization is the process of making the powder behave like a liquid. So that will be anyway used in the pneumatic and the hydraulic convey. So we look at it and solve this. See how the flow is happening. How pneumatic transport is happening. See the zoom, how close you are with the particles. So the more closer you go, you will be able to see that there is the gap. Sometimes they are colliding, so that may lead to the breakage. So that is the one of the disadvantages, and they can collide with the ball, and also the ball can get aberrated, or there is the cracks coming up. So that is the whole point of this discussion. So that these are the different things that could be found. You see how the particles trajectory is being discussed. So that was it for this. You look, you now solve this question. Now look at this. I hope you have actually gone and read the question carefully and tried it. While discussion of fluidization, it has been clearly explained that the how Froude number is the one that actually takes care whether the what regime the fluidization is happening. It is aggregative or the particulate one. So that was the main thing that we have already discussed somewhere. Let us let me just see. Yes, yes. So some glitches there. So fix it. Yes. So that is it. And if you see this, the correct options are so Froude number. If it is less than one, then it is a particulate fluidization. So this is the D option. So Froude number less than one is the particulate fluidization. So this is correct. And Froude number greater than one is the aggregative fluidization. So B and C is correct. B and D is correct. Correct choice. Okay. Now other two are the value of n has been defined by Rice et al. In 1958 and Remo et al. In 1962 proposed four-dimensionless group to characterize the quality of fluidization, and that n, that is nothing but the combination of the Reynolds number at the minimum fluidization and the Froude number and the density. These are four-dimensional number. Dimensions group 1, 2, 3, 4. So here the condition is n less than 100 means particulate fluidization. Okay. So B and C is correct answer. B and C is correct choice. Okay, so that is it for this particular question, and we have already discussed about various uh, fluidization techniques, and we through the video also we have uh, had somewhat control over the things in hand, and now I will be yeah, just wait. Let me just take this. Yes, let us take this here. Yes. Okay. Yeah, this is the video that I was.
If we slow this down, we can again see that the small material moves down.
Okay, this is it.
The rate at which particles settle in a fluid is relative to
So
their
we want to
diameter.
find this sedimentation.
Here,
settling
we see a negative 3 feet settling in a quiescent body of water.
by
If we mix negative 3 feet and negative 1 feet, the rate at which particles settle in a fluid is relative to their diameter. Here, we see a negative 3 feet settling in a quiescent body of water. If we mix negative 3 feet and negative 1 feet sediment, coarse material settles faster than the finer material. If we slow this down, we can again see that the small material moves down or settles slower than the coarser material. This is again seen if we mix negative 3, negative 1, and 1 phi material. We see that the finer material spends much longer in the fluid settling. In fact, in this
You see,
situation,
there
you
is
can
a
see that
circling
there's in
happening. You
fact a
see,
graded bedding at the bottom,
interface is
which
increasing
formed
slowly.
in just a few seconds, while quite a bit of material stayed in the water column and is settling over time. In this situation, it took at least 80 minutes.
So till then, let me just. So you are staying for some time.
It took so long, in fact, that the video had to be sped up to a time lapse, which you will see here.
To see how upper thing is getting clarified and all the particles are getting sedimented.
In the end, what we see is graded bedding,
So
as
this
shown
is like
here.
thickener and the classifier.
Coarse material at the bottom, finer material at the top. Here, four different fee
You
sizes
see the
were
comparison.
settled at the same period of time.
So different
Once again,
sizes,
note that the fine material spends much more time suspended in the water.
so you are able to see that how much time delay is there, and these were the questions that we have already solved. And let me just increase the brightness a bit. Okay, so this is done. So some network issue is there, so let me just fix it. Yeah, no, I think so. Yeah. Now, which of the following statement is correct? So, which of the following statement is correct? The killers are the concentrated sludge if it's desirable. Clarifiers are uh, clear liquid from the suspension if it's desirable. Okay, this classification is decided by what is desired or non-desired, undesired. Depends on system and material getting sedimented. About thickener and clarifier. Okay, you look at this. This is the question. You look at this and solve 1 minute. We will be discussing it. So I hope you have read this question, and the solution to this is let me just fix it. So, yes, yeah. So this is like this is the correct one. If there is a desired one, then there will be this coming up with the picture. So that's the correct one. Yeah, this depends on. So A, B, C is the correct answer. Is correct. Okay, so this was the correct answer for the given problem in hand. And what are the different factors affect in sedimentation? Which are the factors affect sedimentation? Options are turbulence, bottom score, then spell stability, and bottom score, and then fluctuation. And here, these are the options. You just try it once, then we will be solving it. So which of the following is correct answer? Let me make the view green. I think that will be much better. No. Another one is any negative here. So which of the following factor affects sedimentation? Option is turbulence, stability, bottom skirt, and the fluctuation. Solve this. So if you see the turbulence, the option one is what turbulence actually does is uh, what turbulence actually does is uh, if in any sedimentation happening sample system, if there will be more turbulence, the flow is your flow. If the flow is more turbulent, then the settling of the particle will be slow. So you will have delay in the settling or overall settling. Okay, and uh, that is again the thing. Like if this turbulence is more, and usually in some systems it is there, so it has to be avoided. And then if you see this stability, so instability can result in the short circuit flow, and that will influence the settling of the particle. So there, because of the instability, there will be undulations coming up, and the growth of those undulations leading to the short circuiting or discontinuous flows. Another one is the bottom skirt. So this is like during bottom skirt, settled particles are resuspended and washed out with the effluent. So that is that is the thing. If the resuspended, they will settled particle will get resuspended and they will get out or washed out. Will washed out with the effluent. Then there will be a, a decrease in the efficiency of the overall systems process. And the last one is the flocculation. It results in the larger particle increasing the settling velocity. So that's it for this particular problem. And now you see all the options are correct answers. So let me just take the pen. All the options are correct answer to the given problem. So now let me just look at the week one content that I have explained that time. So I now for half an hour or 20 minutes we will be discussing what we have already discussed. So in the first week we have had the discussion about like which among the following is not a unit operation, and that discussion today also I have discussed. Success or the failure of the product depends on the size of the particle, and definitely this course was all about the size and how the various mechanical operation processes are being done, and this this actually revolved around the particle. Also, in the sedimentation, what happens? So this phase separation occurs. That is the main criteria of the collection of the things. And the sedimentation depends on obviously on the pressure, velocity, viscosity, and the shape. So all of the options are correct here. Something about the free settling. There has been one question for larger height of the sedimented, higher concentration sludge will be found. And which of the statement is not true for batch sedimentation test? So that is initial height of the compression zone increases and then decreases. That is not correct. Uh, because what actually happens is compression zone height will keeps on increasing. There will be nothing like that. and then transition zone stays for longer. Transition zones will disappear at T infinite. So it will not stay. So here not true is the C option. And now something about in the 8th question we saw that the critical sedimentation time, there was a question. So all the particles enter in the compression zone and the sedimentation zone disappears. These were the discussions about the same, and we had uh, overall discussion about the questions in hand. So this was about the sedimentation. There is no wall effect of the wall. There is no effect of the particle. There is the settling and the gravity, and the particle concentration should be less than 1%. So that is it for the free settling. And then this how this higher height of the sedimenter leads to that explanation we had through the more height of the sedimenter means more resistance time for the sedimentation, and that leads to the more solid settling, and that consequently ultimately leads to the more concentration of the sludge. So this coal beneficiation process also we had one problem, like uh, there is no continuous sedimentation for the filtration, but in the coal beneficiation organic process in which the inorganic impurities are separated from the uh, remain coal, thereby providing improved combustion characteristic to the fuel that is being processed. So that was some questions that we have already had discussion on in the week one, and also some numerical problem we had about the calculation in the batch sedimenter, and what happens during the flocculation is like sedimentation process becomes faster because of the flocculation. Which one of the following is not the synonym of the unit operation? We had unit operation is what? Like it is a particle technology, mechanical operation of the particles, particulate technology. So Arthur D. Little is the one who gave the concept of the unit operation, and he introduced it first time in the literature. Tube circulars are used when clear liquid is desired product, that is clarifiers are desired product. Also, the purpose of the rakes in the sediment is to direct the sludge to the center of the tank so that it actually comes out. And why the feed enters to the tank at a depth from the top? Because if turbulence occurs, then the turbulence may lead to something called like short circuit can also happen, like the instability one, and that's all. So something about separation of the solids is faster in the centrifuge, so centrifugation is the one that are being done. So this was the overall content about the first week, and in the first week we were actually this was the solution of the problem, and in the first week we have actually discussed greatly about the one that I was talking about is the sedimentation in the advanced sedimentation, and the and the continuous sedimentation. Okay, so and in the week two we started with the numerical problem, and in the numerical problem we had numerical problem on what we call it filtration and solid liquid separation, and there you see the volume flow rate during the constant pressure filtration is given as this one, and you were asked about the factors that are coming up, Kc and Q naught. So that has been dealt with thoroughly. So some numerical problems we have solved it here, and also in the constant pressure filtration, this was the constant volumetric flow rate during the constant pressure filtration. So about the constant pressure filtration, we had many discussions, and also we have had a discussion on the specific cake resistance. So in the specific cake resistance, we have discussed that this actually is the function of the pressure drop and the compressibility coefficient. So this, if you see in general, one of the correlation that has been given, and that says that alpha equals to alpha naught delta p to the power s, and where if S is 0, the cake is said to be non-compressible cake, and if S is 1, then it is a completely compressible. But in general, it is a value in between. So based on that, we had one numerical problem and we have solved it for the two cases, and we came to calculate the time. And another problem was this one. This was constant rate filtration. We had two questions on constant pressure, and this was one was on the constant rate filtration. And again, uh, we have solved a bit good numerical problems on this. Okay, so that was the one thing. Now we have had some of the theoretical related problems, like for the toxic sludge, which type of filters we will use, filter media is used. So we came to know that the sand beds are being used for the toxic sludges, and about the V value is the volume of the cake formed when 1 meter cube of the filter is collected, and also the optimum cycle time for the filtration is equal to the difference of the time for which the filter is out of the use and time of washing. Also for the constant rate and compressible sludge, this compressibility coefficient alpha 0 and the Rm should be computed, and based on that the slope graphically, as we have discussed, the graphically in the lecture also you have been taught that graphical representation through the slope and the intercept, you were able to calculate the properties of the filter media or the filtration process. So based on that, we had some numericals uh, or related numericals, like 6 is related to the 5, and we have had calculated the some question about the continuous filtration. If 25% of the area of the drum is in contact with the slurry, the value of F should be. So the value factor F we have calculated, and in the continuous filtration, constant rate occur with the constant pressure. So that's it. So based on that, we have solved some of the knife is used in the disc filters, thick thin cake is formed in the drum filter, and in filtration, alpha account for what resistance of the total cake. And based on that, another problem was which of the statements among the following is correct for the vacuum filtration. So we have had that also. Less dry cake is obvious. So similar to that, today also we have solved one question. So that was it about the question that we have already solved. And now this was about the week 2, and in the week 3, the things we have started with the fluidization, and especially the fluidized bed we have discussed. So so I will be telling you about the same. And in the 4th week also, what we have done, we will be discussing. So in the 3rd week, we started with the basic fluidized bed, like bed height increases at a constant pressure. How it happens, the what is the principle and the mechanism of that. Through the lecture notes, we have had discussion. Bed height increases at a constant pressure drop. So we have had pressure drop to that UMF. That is nothing but the fluidization velocity. So there we had one situation when the pressure drop is highest. There is this minimum fluidization situation. So here you see this as this is happening, pressure drop became constant, and here the pressure drop became increasing with the velocity. What is happening to the fluidization height, fluidized bed height? So that's what bed increases at a constant pressure drop. So if the constant pressure drop is there, then the fluidized bed is increasing. So that was the first question. Second question was, at minimum fluidization condition, the particle starts leaving its place in a bed. It is correct, because they will just start leaving its place. Okay. Also, about the same, we have had different situation in the fluidized bed, like fixed bed, incipient fluidization happened. Fluidized bed is getting formation of the fluidized bed is happening, somewhat good condition of the fluidization, and then there is the bed and there is the pneumatic transport coming up into the picture. So So that was it. Galileo number also we have discussed that it is the ratio of terminal velocity, settling velocity to the minimum fluidization velocity. Uh, but if the Galileo number increases, terminal velocity ratio of the terminal velocity to the minimum fluidization velocity decreases. Okay, so that we have discussed based on the Galileo number definition also, and also you had this Galileo number and how this is having its decrease. So that was there in the notes. More irregular particle if you use, then there will be a decrease in the bed voidage. So that is the one point. Because of what? If it is irregular, then there will be less sphericity, and based on that, you can relate it to. Uniform expansion of the bed is not achieved in high gas velocity. So uh, that's what is the one. If you are having very high gas velocity, so the condition, the situation for the particulate fluidization and the aggregative fluidization we have discussed, and which one is good. So with the liquid, the bed continues to expand as the velocity is increased, and it maintains its uniform character with the decrease of agitation of the particle increasing progressively. This is known as the particulate fluidization. With the gas, however, uniform polarization is frequently obtained only at a low velocities. At higher velocities, two separate phases may form a continuous phase, often referred to as the dense or emulsion phase, and are discontinuous phase known as the lean or the bubble phase. The bubble fluidization is at this stage is said to be aggregative fluidization. So for a given terminal velocity, operating fluidization velocity is, it increases with the increase in the bed voidage. So you can relate it with the formula over here, and the value of n is higher for what? Larger particles. So based on that, we had some numerical problems also we have discussed, and then again we have had some of the uh, statements about the particulate fluidization followed by the aggregative. We can see here particular fluorization actually happens at a lower flow rate, and uh, here we had seen that the needle is very difficult to fluidize. So sphericity is the one that actually plays its role in the fluidization, and various types of uh, the the powder we had. Like here we had this maximum bubble size can be achieved in type A. So various types we have had. So type A was when they fluidized by the air at ambient condition, give a reason of the non-bubbling fluidization beginning at UMF, followed by the bubbling fluidization as fluidizing velocity increases. And powder of the group B is give only bubbling fluidization under ambient condition. That way they will not give particulate fluidization. And powder C is, they are very fine cohesive powders which are incapable of fluidization in the structures. And also the 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 group D powders are the large particles that are distinguished by their ability to produce deep spouting beds. Okay, so these are some options. These are some examples, and we have had the most suitable thing for fluidization is the catalyst one. And about the fluidization, we had this situation also. Sludge is undesired due to vibration in the industry. Why slugging is undesired? When the size of the bubble is greater than about one third of the diameter of the equipment, there is rise in the velocity is controlled by the equipment, and they become sludge of gas. Slugging is atta- attended by large pressure fluctuation, and so it is generally avoidable. So this is kind of cavitation kind of thing, large units, and there will be vibration caused. So another one, if fluidization is not used in size reduction, it will be used in mixing of the solid, hydraulic transport, and the pneumatic transport. So, Karman-Kozny equation is valid for the laminar flow. We know particular fluidization occur at low velocity, low gas velocity. So all the discussion we had. Minimum fluidization velocity is greater for the non-spherical particles. So that is the again the sphericity one. Uh, Spouted bed fluid is most suitable for what? Drying of the solid. So that they are spouted bed, you know that the spouted bed fluids are used as a efficient dryer for the drying of the seeds such as rice and the wheat for higher moisture. So moisture content can be here. What happens? The spouted bed represent the ultimate in the channeling in the fluidized bed. Gas enters at the conical base. In the between when it is happening, with the much of its flow rate rapidly upward through the central core, and this remainder percolates through the what? Through the surrounding solid, which may not be fluidized state. So some numerical we have solved, and some more problems about this transport disengagement height, and then which of the following is an application of the fluidized bed or fluidization. So about the application of fluids. And in the last week we had discussion about the conveyors also, and at the same time we had discussion about the flotation. So we have had some of the videos in the discussion about the conveyor belt we have discussed, and about the froth flotation, and we have acknowledged these people during that. And these were the some of the problem with the flotation cell, flotation process. Resistance time is more for what, for less, how the contact angle plays its role, and what is the conditioner in use inside the cell for the mechanical flotation cell, and some questions about the the apron conveyors, about the conveyor overall, and that's it. So thank you so much for the for your patience. We have had modified floaters, this present and collector of promoters. We have discussed about them. uh, these are the flotation agent, and they help in the flotation process to happen properly, and we have had discussed it through the flow diagram about the selective flotation of the silica. Through that you have had separation of the recovery of the galena, ferrite and pyrite. We have discussed about the all, along with the role of the NaCN, and pine oil and the lime. So these and the steps of the flotation we have discussed. So these were all about the course and the weekly contents that we have had discussion. So thank you so much. Thank you. Let me just close it first. That's it for this. Okay. Thank you so much. Okay.